Hello all, welcome to this course Statistics for Biomedical Engineers. I hope everyone enjoyed this course taught by Professor Babji Srinivasan. I am Karthikeyan, the TA for this course. Now we will see an introduction to Python and how to execute the various topics such as probability distributions, central limit theorem, linear and logistic regression taught by Professor during these classes. What is Python? Python is a high-level interpreted programming language. It knows as its readability and simple syntax, making it ideal for beginners. It's widely used in web development, data science, machine learning and automation. Python is excellent for processing, analyzing biomedical datasets. Easy to learn and use. Basically, Python is a simple syntax similar to the English language. So, interpreted language, Python executes the code line by line, makes easier to debug. This is a cross-platform, works with various platforms such as Windows, Mac OS and Linux. What are the modules, packages and libraries for the Python? So, for Python, a module will be a single Python file containing a code such as functions and classes are there. Packages are a collection of modules bundled together. Libraries are a collective of relative packages that provided extensive functionality. Example, NumPy, Pandas and TensorFlow. We are going to see the Conda overview for Python. Why the Conda? Conda is a package and environmental management tool, handle dependency and packages efficiently for different projects. Worked across multiple platforms and programming languages. So, Python is one of the programming language in the Conda. We are going to look into the installation of Python via Conda. During this installation, we are going to see how to use for Windows. So, this is the website which you are able to download the Anaconda. So, here the website you can see Anaconda. So, from that you are able to go to products. In the products there is a distribution will be there. You just click into the distribution, you will get this page. This page you want to do, just give the skip registration, and for then after that it will ask for if you are going to install it for Windows, Mac or Linux. So, first we are going to install for Windows. So, I am choosing Python 3.12 for Windows. So, it's while clicking that it will go to downloads. So, after downloaded you just double click to open that application and run this application. Okay. From that here we will go to this page, welcome to Anaconda 3. You will click on the next button and after that you click I agree, and after that you just click next to give all users, and you just click next and install. Now it will take some time to install the packages, and after that completing the installation you just click next and click next and finish. That's all, you are installed Anaconda tool to run the Python code. Now you just go to the start in your Windows and go to Anaconda Navigator, and from that there is a Jupyter notebook. You click launch. It will give ask you the permission to open in Google Chrome, Firefox and whatever installed application you have. Just click on that application like any web browser, give always, and it will go to this page in your application, web application. It's a local host, so that here from here we are going to run the Python codes with the notebook. So, you want to click new and click notebook. From this you can able to run the Python codes through the Jupyter notebooks. Okay. Now you can write whatever code you want to and you can run the code from that. Now we are going to understand how to run the Python code through the Conda environment. So, Conda environment is a creates isolated environments, ensure the dependencies between projects don't conflict, and it can install, update and remove packages within this environment itself. So, this is the Conda workflow. You want to create environment, install package and launching IDs are there. So here I am going to show you the each step for how to create the environment and how to install any Python libraries and all. Okay. Now you just go to start. After installing the Conda, you just go to start. You can type Anaconda. You can click on the Anaconda prompt. It's a command window. It will open. In that command window, you can type Conda create hyphen name. Then whatever name you want to type, you can type. After that, click enter. You will go. It will ask proceed for creating the environment. So you just click Y and give enter, and after that it will after completing the installation of the environment, you just able to activate the environment, so that you can give Conda activate whatever the name you have given previously, you can give the name here. Now you want to run the Jupyter notebook through the Conda environment, whatever environment you have created, so that you can see the environment, the name change from base to whatever name you have given. After that, in that you can give pip install Jupyter lab, and after that you want to install pip install notebook from the Jupyter lab. So after installing the Jupyter notebook, you just type Jupyter -notebook and give enter. So it will take to the page which we have previously discussed, same Jupyter notebook through the your browser, and here you can click the notebook, new notebook, so that you can go to this page and you can click select of Python 3. Now you can execute the codes. Thank you all.
Now that you have understood the basics of good practices of installing Python, how to use Python actually using an environment, let us go to some basics of Python, and then we will understand the biomedical stats behind how to use Python for biomedical statistics actually. So let us delve into Python class actually. So initially let us understand what is a variable and different types of data types actually. Okay. So consider this actually, I have declared a variable here. Age is a variable, height is a variable, name is a variable actually. I have declared age to be 25 and height to be 5.9 and name to be ls. So if I print such things, actually print command helps to print what we have given inside the variable. So print, if I am putting print name as name and print the thing which in the braces is a string actually. The whatever you put inside the braces will appear as it is actually. So when I am printing name and giving the input variable name, it will, the resultant output would be Alice. Resultant output would be Alice. So if I am printing age, the resultant output will be 25, since I have inputted the input variable to be 25. And if I print height, it will be obviously 5.9 actually. So here I am just introducing you to an integer, a float, as well as a string. By integer I mean 25 is an integer, by float I mean 5.9 is a float, and by string I mean Alice within the quotes, within double quotes actually. So further if you want to understand more about Python, you have to know something about this actually. There is something called list, there is something called tuple, and there is something called dictionary. So if you are representing something in a list, it has to be in the means of using a square brackets actually. So square brackets of apple, banana and cherry. So this indicates that the list has 3 elements inside it. The index of these elements are 0, 1 and 2. So in Python it always begins with 0 and ends with the length of the list minus 1 actually, which is 2. So tuple can be represented using a round brackets like 10 and 20, and finally dictionary. Dictionary is something which is represented in terms of q value pairs. Here name is a key and Alice is a value actually. Age is a key and 25 is a value. So this are something which is needed to run more things on Python actually. So let us delve into some more basic math operation that is being used in Python actually. So consider this. I am declaring a variable x and giving it as 10, and I am declaring a variable y and I am giving it as y, giving it as 3 actually. So I am giving, I want to perform certain operations, certain mathematical operations. So I am giving x plus y, x minus y, x minus x multiplication of y, x division y, x modulo of y. So when it does this, it takes the input variable x and y and performs such operations. So it is a bit direct here in Python actually. So if you do this, you will get an addition, the resultant of 13, 730, the 3.333 and modulo of 1 actually. it is rounded to 1, fine, modulo. So string concatenation. So I have already said in the first first cell that Alice I mentioned in the double quotes. Similarly, I am giving first name as John, last name as Joe, and full name I am putting it as first name plus with the space within double quotes and the last name actually. So I am printing the first name full name as to be like John Doe. So I am giving the first string comes as John, then comes as space, and then comes the Doe. So we have already known that to take something it has to be indexed actually 0 1 2. So here just to show you that I'm able to take the first letter in the full name as J using this particular indices. So if I put full name of 0, it will be like J, the J character reveals outside actually. So if I want something from the back end, like for example DOE, the Doe, the second full name of that person actually. So what I'll do is I'll put a colon and then put a -3. So this indicates that it will take the last 3 elements which is there in the string actually. So it gives us DOE. So then this is one of the important things which you should know in the Python actually, if it's an if else condition actually. So I am giving an variable age and declaring it to be 18 actually. So I am giving 2 conditions here actually. One, if the age is greater than 18, you have to print it as vote, and if the age is lesser than 18, which means in the sense that I have put an else loop. So if the age is less than 18, it has to print you are not eligible to vote. So I have declared here, I have already given an input of age is equal to 18. So it checks the age whether it is greater than or equal to 18. If it is greater than or equal to 18, it is printing as you should be eligible to vote, and if it is lesser than 18, it should print as you are not eligible to vote. So it says that here, since the age is greater than or equal, then the age is 18, so it prints it as you are eligible to vote. So next, a for loop. This is also an important concept we should know. So for instance, range, what does range gives? It gives all the elements from 1 to n minus 1, which means 10 minus 1 actually. So it starts with 1 and ends with 9. So here for I in range of 1 comma 10, what it does it? So it takes the first element 1 and it gives to the next line, print of I. So I becomes 1 and then it is printed as 1. The next time I becomes 2 and it gets printed as 2. And the next time I becomes 3, and similarly it becomes n minus 1, that is 10 minus 1, it will print till 9. So while loop is similar to for loop, but here we don't need to declare it as for I in range. We just have to declare like while count is greater than 0. I have declared here a variable count and I have given it as 5, and I am saying count should be greater than 0. Count should be greater than 0. So again it says that count is equal to 5, so it enters into this first loop. So again it starts printing the value of count. So what I have done here is I am incrementally decreasing the value of count actually. So here what it does, it takes the value of count and it decrements by 1. So now the count becomes 4, which is again greater than 0. So it prints as 4. Then it becomes 3. Then it is printing as 3. Then it becomes as 2. Then it will become 2. Then it will become 1. So when it becomes 0, it should be greater than 0. So there the loop ends. This is an example of while loop. So let us understand some list manipulation in Python actually. So here I would have declared the variable fruits. Inside it I have entered 3 strings inside a list actually, apple, banana and cherry actually. So this fruit should have apple, banana and cherry. So one thing I want to add is I want to add an element called orange inside this list actually. So what I'll do is I'll use a function called dot append. So I'm taking the variable, I'm putting it as dot append, I'm putting it as orange actually. So fruits dot append of orange results in this apple, banana, cherry and orange. And similarly, if you want to remove an element banana from the existing list of 4, so what I'll do, see, remember now since we have appended, it has become 4 actually. There is 4 element inside the list. So what I am doing is I am using a function called inbuilt function called remove. So I'm using the variable which is declared to be 4 elements. So fruits dot remove of banana actually. So it will remove the second element banana and it will print the rest of the elements, that is apple, cherry and orange. So let us understand what a function means in a Python actually. So how to represent a function in a Python, how to do it actually. So to represent something in a function, we have to use something called def. Def is how a structure or a procedure to write a function name actually. So def greet is the name of the function, and name here declares the input which is to be fed inside the function. So what I'm doing is I'm creating a function called greet, inside which takes an input name. This input can be anything actually. So what I'm doing is then I'm just printing the name, and how you should end a function is you should put a return, and then you have to put whatever functions you have done, whatever operations you have done, and you have to give the resultant output actually. For instance, I have just declared the input name, and I'm just giving a string hello and putting a name, the resultant output as name actually. So what it will do is it will print hello name. So remember this, I'm putting concatenation on both sides, and I'm putting both plus on both sides. So what does this means? It will concatenate hello with the input variable name actually, with the value of the input variable name. So for here I have printed greet of Alice. So here Alice becomes the name actually. So what it will do is it will go inside the function name, and it will first print the name Alice, and then it will return hello Alice and then exclamatory mark. So see the result actually. So it will just print this. Here we have written print, so that is why it is giving print name of Alice, and then this is the main function where it is calling us. It should return the value of the function greet. So here it returns hello plus Alice. So hello comma Alice it will say. So hello comma plus concatenated by name. So it is resulted as Alice. Hello Alice. So this is how you should define a function in Python. So let us understand something more actually. So if you want to make the Python to be more interactable, what we'll do is we'll usually add a function called input actually. It accepts the input which we want to give it to the Python actually. For instance, if I'm using name is equal to input of, like for instance, enter your name. So what it does is it will ask a command actually. It will ask a command, and there you have to enter your name actually. For instance, I am putting when I am running this, it will call it as, it will ask for an input actually. It will ask for an input, and then based on the input, for instance, like I am typing my name. Okay, I am typing my name as Anish. Then I have to click on enter actually. So it says hello Anish. So it takes the input from my end, that is entering my name Anish, and then it just prints it out actually, because I have just declared a function called print actually, nothing more. So this is how you can make Python to be more interactable. So this is one of the important concept called an object class actually. So what does an object class does is it helps us to call these functions irrespective of the folder which you have placed, and irrespective of different functions inside the main function actually. So for instance, I have declared a function called dog, declared an object called dog actually. So it is written as this is how we should represent an object class. So class dog. Then this is how you should initialize something actually. So whenever you are using an object class, you have to put something called initialized self, and whatever variables you are going to declare inside this. So initialize self, name and breed. Here I have put name and breed. So what I am doing is self name dot breed, self dot breed is equal to breed. So if I am giving something, so there are two inputs here. Remember, there are two inputs. One is the name, and there is a breed. So this class dog accepts two input. One is name, and the other is a breed. So it takes two input, and here what I have done is I have again made a simple function called var. So in which returns the name of the dog, and it says that the name followed by saves oof actually. So when we run it, what it will get is, so see here. I'm calling the object class, and I'm giving two inputs as I've given here actually, name and the breed. So Buddy is the name of the dog, and Golden Retriever is the breed of the dog. So what it has to return is, it has to return only the name, and it has to be followed by says wolf actually. So if I'm printing this my dog dot bark actually, so this is how I should call the class object actually. So here I'm calling the class object my dog. So this is how here I have already declared a variable called my dog, and I'm calling the object class here, and then I'm calling it as dark bark actually. So I'm calling the main function dog, and then I'm calling sub functions inside the object class, that is bark actually. So my dog plus bark actually, my dog bark actually. So what it will return is, it will return the name, that is Buddy says wolf. So when you print it, it will say Buddy cell proof. Hope you have understood it. This is one of the important class. I'll just go through this once more. So to declare object class, we have to define something like class. So this is structure of which we should declare it, class, and the name of the object class actually. So inside it we have to initialize the object class, and then the functions which we want to use inside the object class. So here I have used a function called bark, and which returns just the name of the breed, followed by I have written a string called says wolf. So whatever it returns, it has to be returned as the name of the dog followed by says wolf. So Buddy says wolf, since Buddy is the input here, Buddy is the name of the name inside which a function class is being called. So far we have understood some basics of Python actually, and we have understood what is an if-else condition, what is a while condition, how to call a function, how to call a class, what is a list, what is a tuple, what is a dictionary, and how to declare a variable, how to declare a variable with the integer, with the string, or with the tuple, or the float. So moreover, we have understood some level of appending to a list, and some level of removing a character from a list actually. So these are functions which we can do by ourselves actually. There is no need for something externally to be imported inside a function. So but these people, these organizations, so some organizations have developed certain inbuilt functions, so we can just call their inbuilt functions, and we can make use of those functions. For instance, I am calling a function called math. So what it does, it has multiple sub functions inside it. For example, sum, add, minus, subtraction, all those things it has inside it. So particularly I am calling a math function. I am asking it to perform a square root function of 16 actually. So I don't need to put square root of 16, I don't need to put mathematical formula to do it. I'll just call the function called math, and I'm just I'm just calling the sub functions inside the math, and I'm performing certain operations. So here math is a library actually. So I'm importing a library. So this is how you should import certain libraries from external sources actually. So I'm importing a library called math, and I'm just performing an operation called print square root of 16. So I hope you understand actually what a library means actually. So this is how you should import certain libraries. For instance, you can import multi libraries. For instance, import numpy as np, import matplotlib.pyplot as plt. So this is how we should import certain libraries or certain packages which are found externally outside your systems, or which are not built inside your systems, and you can download such libraries and make use of it. So I have declared, I have given some works actually which you can go through, but I'll just make a quick skim through of what I have done actually, so that when this notebook is being shared with you, you can run this, or you can change few things and you can try it out. So here, just to make sure that you have understood a Python to a bit more. So what I want to do is, it's just a simple task. So I want to print numbers 1 to 10, but what are the multiples of 3 or 5? So I want to check in the number of 1 to 20. If it is a multiple of 3, I want to print fizz. If it's a multiple of 5, I want to print bus. If it's a multiple of both 3 and 5, I want to print fizz and bus. So what I have done, I have taken a for loop and I am calling the range from 1 to 20. 1 to 21 indicates 1 to 20 actually. So I'm checking whether the number is divisible by 3, or if it is divisible by 5, it has to print fizz bus, because the question is that if it is only divisible by 3 and the remainder is 0, it has to be fizz, and if it is divisible by 5, it has to print bus, else it has to just print the variable I. So this is how an output would be. Just try this out. And again, I have made certain operations like these are some things which you guys should try, but still I'll go through it a bit. So I have written it is write a program that takes two numbers as input and prints their sum, difference, product and quotient. So I have declared a function called arithmetic operations and I'm giving two variables called a and b. So I have declared a function. So it returns a dictionary. Yes, it returns a dictionary since it is followed by braces, flower braces. So it is followed by key value pair. So here the key is sum, the value is just a plus b. The key is difference, the value is a minus b. So if you run it, you should get something called this actually, sum, difference, product and 5. So I am checking the number, I am writing a program that checks if a number is odd or even. So if a number is divisible by 2 and the remainder is 0, then it is even, or else all elements are odd. So I have done it simply, I have created a function, I am just checking it directly here. I am checking if the number is divisible by 2 and the remainder is 0, it has to print it as even, if else it has to be written as odd. See, this can be written as if n modulo by 2 equal to 0, print even, else print odd. It can be written like that also, but this helps us to make sure wrap it up within a single line. So when you are declaring a variable called 5, when you are putting in input 5, it declares it as odd. So again, a function which calculates, which converts Celsius to Fahrenheit, just use the formula. Directly I have used the formula. I am just taking the input of Celsius and I am multiplying by 9 by 5 and adding 32. So if I am putting a Fahrenheit of 5, Celsius to 5, it will say it is a Fahrenheit of 41. So similarly, so for instance, if you want to calculate the PNR, simple interest of a value, so I am creating a function, I am directly using the formula here, I am giving 3 inputs here 10, 5, t. So it will result, it will just calculate and give an output of 50. So then the next step is I am going to find the maximum of 3 numbers actually. So what I am doing is I am creating a function, I am calling all the 3 inputs and then I am returning max. Max gives the maximum of all the elements inside an array. The array can be a list and array can be simple array. So it gives among 3 elements, for instance 10,000 and 10, 100 and 1000 actually. So it gives the maximum of these 3, that is 1000. So again, a program to calculate the sum of all numbers inside the list. Remember, here I have used as an array and here I am going to use as a list. So such operations can perform all elements inside the list as well as an array. So it performs the operation of sum between 10, 100 and 1000. It is 1110. So again, Python doesn't only gets not only to numbers, but it can be also driven to strings. For instance, I am just checking whether a number is palindrome. That is, the same gets repeated when the same elements inside a word should be the same, even if you are coming from backwards. Actually, I am just checking whether an input which I am going to give is a palindrome or not. So I am checking s is equal to s of colon and so on. So what does it? It checks all the elements from the reverse. Actually. So for instance, I am giving a input called civic. So civic repeats both sides same. CIVIC. So CIVIC. So it is returning a variable called true. So the next is I am just counting the number of vowels inside a sentence or a character or a word. So what I am doing is I am creating a function called count vowels, and inside which I am already predefinedly saying it to it that these are the elements which are going to be a vowel actually. So A, I, O, N, A, O, N, so lower and smaller lower braces, lower and upper characters actually. So I just want to know the number of vowels inside the character actually, inside a word actually. So what I am doing is I am writing a if function inside a for loop. So what it does is it takes one elements from the vowels and it checks with the input and it checks with the input character that is being put. So I am predefinedly saying that vowels is this, and I am going to check going to take each elements in the input variable and I am going to sum it up actually. I'm going to check it with the corresponding vowels, and I'm going to sum it up actually. So here the input, so the input is civic actually. So civic comes in. So for all elements in S, which is civic, so it will check it will check whether it is there in the vowels. It will cross check with all the elements in the vowels, and if it is, it will just increment by 1 actually. It will just add it by 1. So it will add, since the number of vowels inside the civic is 2, I and I, so it will count to be 2. So again, I want to calculate the factorial of a number. So I'm just using factorial factorial formulae and just putting, and I'm just getting the result actually. So I want a factorial of 3. I'm just getting printed as 6. So I want to reverse a list. Remember, in palindromes we have done the same thing actually. So I want to reverse a list here. So I'm just taking all the elements from the reverse. So 6, 5, 34, 2 ones, 1. So find the largest elements in the list without using a function max. So we studied that there is an inbuilt function called max, which we can use it, but can we do that without using certain functions actually? So I am not importing anything, I am not using any function called max. So I am writing my own function called find largest, and what it will do is it will take all the elements inside the input and it will check with each element actually. If check 1, it will check 1 with 2. If 2 is greater, then the largest number is 2 for the time instance. Then 2 it will check with 34. If 34 is greater, the largest number is 34. 34 is being checked with 5 actually. Still 34 is being largest, so 34 is still in the largest number. So 34 is it will be checked with 6. So 6 here, 34 here. So the largest number is still 34. So it will return the largest number of 34. I hope you guys have understood some basics of Python and some knowledge of Python actually. So in this class so far we have understood some basics of Python, where we can define a function or define a string or define a class or make use of this Python, import certain libraries or import certain functions, make use of the libraries, or develop your own function without using the libraries, make use of list, append a list, decrease a list, and all such things we have understood. So let us now understand our subject actually, how we can implement certain things in our subject. So some Python examples or some things to understand more about the subject, that's showing that Python can be used to replicate whatever that was taught in the class. So some understanding of random variables, expectation, variance, distributions can be done using Python. Here you have to, as I said in the previous class, that this is how we should import a library. Remember, we have studied in the previous class that we have imported something called import math. So here I'm importing a library called NumPy. I'm declaring it as NP here. So first you guys have to install the library called NumPy actually, for which I'll just write a command. So pip install NumPy. So if you run this command, the packages will be directly installed in your Google Colab or Jupyter Notebook or any function. Since I've already run it, I'm just putting a comment out of it so that I don't need to run it again. So we understood what a random variable is actually. Random variable is something that maps a sample space to a real line actually. So here die roll is a random variable, so for which I am just declaring certain values inside a list actually. So what does this np.random.randint does it? It will give us certain elements from 1 to 7 and the number of elements to be 10. So it will give 10 values between 1 to 7 and it will be randomized and it has to be an integer. That is why we are using a function called np.random.randomint. So if I am printing it, it is the resultant output will come. So we have So this is just a random variable. So we know that expectation of something, expectation of random variable is a mean. So how to perform it? Remember, I have already declared numpy as NP actually. So I am calling that NP and I am using an inbuilt function inside the NP called mean. So NP dot mean of die roles actually. So all the elements. So take the mean of all the elements inside the inside the list of die roles actually, inside the random variable NP. Die roles actually. So die roles of all the elements of this 3, 6, 3, 3, 1, 4, 6, 3, 6, and I am taking the mean of this actually. So if the mean of this, if I am taking the NP of mean of the die roles, the resultant value is 3.6. So we know that expectation of random variables gives a mean. So similarly, we can do a variance of a random variable. So to do that, we have to use a function called np.var. This again is an inbuilt function. We have to just use a np.var and I am calling the random variable die role. So it will give a variance of all the elements inside the random variable. So the variance of all the elements inside random variable is 1.84. So again, just an introduction, random variable, how to declare a random variable in Python, how to call an expectation, how to call a variance. Okay. Now we will look into some part where we can implement certain distributions inside Python actually. For instance, binomial, Bernoulli, Poisson and normal distribution actually. So what does binomial distribution does? The binomial distribution models the number of successes inside a fixed number of independent trials actually. So to import binomial distribution, we have to install something called SciPy. So again here, you guys have to do something called pip install SciPy. So you have to install such things. Since I have already installed, I am not going to run this. So first you need to run it and then you have to run this cell actually. Run this separately, you just have to run it only once actually. So again from the SciPy library, I am importing a function called stats. Inside the stats, I am particularly importing a function called binom, which is binomial distribution. So again, binomial distribution does it needs trials as well as the probability of success. I am giving 10 trials and the probability of success to be 0.5 actually. So I am calling the function binom and I am giving the number of trials as well as the probability of success. Again, to check whether the probability of exactly 5 success, you are going to call the probability mass function inside the binomial distribution actually. So I want to give, so the binomial distribution has 10 trials, the probability of 0.5, the probability of success to be 0.5. Now I am calculating probability mass function of 5, exactly 5 success. So what will be by the probability of 5 success when the trial is 10 and the number of probability of success to be 0.5. So the probability of 5 success will be 0.2460. So to illustrate this, I have declared it in a bit diagram actually. So what I have done is, I have again used the same example. I am giving a number of trials 10 and probability of success to be 0.5 and I am giving a range between 0 to n plus 1, and that range I am going to give as an input to the probability mass function and I am giving the probability trials as well as the probability of success rate actually. So what we will do is, it will just print, it will give us a distribution of how the success rate is getting distributed in a binomial. So what does this does it? Okay, this matplotlib. So I would have already declared somewhere, yes, in the previous code I would have declared it. So here how we should declare import matplotlib lib.pyplot as plt. So first you need to run this and then you have to keep it as it is. So plt.figure is, it creates a figure of size 8,6, height of 8 and width of 6. So plt bar does it create a bar graph with the x of binomial, with the x underscore binomial and the y of probability mass function. So our x limit will be x binom, which is the range of 0 to n plus 1, that is 0 to 11, which is 10, and then it will give us a distribution of binom dot pmf. So I want the color to be blue and I am keeping an alpha value 0.5, the intensity of how the color to be. So I'm giving a title called plt.title, and I'm giving an x label which is the title for the x axis, and I'm giving a title called title for y axis, and I'm putting plt.show. So what it does, it gives us a plot, a beautiful plot of binomial, how the probability of 10 trials with the probability of success of 0.5 is distributed in a binomial. So hope you have understood it. So see here, I would declare a title called binomial distribution, it has come here, and I have declared plt.x-axis title and plt.y-axis title actually. So x label is this, y label is this, plt.show. So when you put plt.show, your result and output will be displayed. So again, next is an example for Poisson distribution. So Poisson distribution models the number of events in a fixed interval of time or space. Actually, it models just the number of events in but in a fixed time interval. Actually, so for which we need a lambda value. Again, that is one thing. So to import Poisson distribution, I'm calling a SciPy, and I'm calling a subfunction inside the SciPy, and I'm importing Poisson function. So Poisson requires a lambda value, so I'm putting a lambda value of 3. So I'm calling the Poisson distribution, and I'm giving the lambda variable here. So I want to observe 2 events, the probability of observing 2 events. So what does Poisson distribution again says is, it models the number of events in a fixed time interval of space. So again, I'm calling the probability mass function in the Poisson distribution actually. So the probability mass function, which is the probability of 2 events, is 0.224. Again, I'm plotting the same thing using a matplotlib. Here I'm declaring ranges from 0 to 15, which is 0 to 14, and then I'm calling the Poisson distribution and the x range, and similarly the y range, which is lambda. So if I plot it, it gives this actually. So as you can see, it models the number of events in a fixed time interval. So it models these events within the fixed time interval of space with the value of lambda to be 0.3. So this is similar to the previous case. I have not changed anything. I have used the same thing for you guys to understand. So the x value, y value, and the color to be green. So Bernoulli distribution. So Bernoulli distribution is the same, is similar to binomial, but it is a special case of binomial. It done for a single trail. Remember, binomial we have given it to be trail to be 10. So there are n number of trails, but here it is for a single trail. So again, I'm calling Bernoulli using from the SciPy.stats. So I'm giving a probability of success to be 0.7. So I'm calling the Bernoulli function, and I'm calling the mass functions inside the Bernoulli. So I'm giving an input of 1 and checking what is the probability of success for a value of 1 for a single trial. So it is saying it is probability of 0.7. So again, here I am declaring a x value of 0 to 1. I am going to say what is the probability of success of 0.7 in an outcome of 0 and 1 actually. So in an outcome of 0 and 1, the probability of success is this 0.7%. So 1, 0.3 and 0.7. Again, this is similar. I have used a plot figure, and I am calling a bar graph. I am giving a title, x label, y label, and next x. So normal distribution. Again, normal distribution is one of the commonest distribution that is being used. It requires mean as well as the standard deviation sigma. So to call normal distribution, we are going to use something called SciPy.stats, and I am just importing the function called norm. I am declaring a variable called mu and sigma, and I am giving it 0 and 1. I am calling the norm function from the SciStats. I am giving a value of mu and sigma, and then I am calling the probability density function actually. So probability density function of 0. So probability density at, what is the probability density at 0 actually? So what is the probability density at x is equal to 0 is 0.3984. So again, I'm trying to plot something probability density function. Here again, I haven't used something called a range or a range. I'm using something called linspace. Since I want to plot something continuously, I'm using something function called linspace. Linspace, what it does is it returns numbers in evenly spaced samples calculated or interval of start and stop. So it is going to give me 100 values between -4 to +4 actually. So this is for continuously plotting something, continuous plot actually. So I am calling the normal probability density function, and I am giving the input x normal and using the mu and the sigma which is declared actually the above. So what I get is a good normally distributed plot actually, the probability density of 0.4 actually, just closer to 0.3. So probability density of 0.4, the value for which it has to come for x is equal to 0. So probability density is 0.4. Then to understand central limit theorem, so what does central limit theorem says? It states that the sum of a large number of identically independent distributed random variable will tend to follow normal distribution. Sir had taken this. We say that the sum of a large number of random variables tends to follow a normal distribution irrespective of the original distribution which they were actually present. So to show that, what I have done is I have imported matplotlib and I am taking 1,000 samples and I am keeping a trail of 10,000 trials actually. So to do that, I have created a random.uniform, np.random.uniform. So it creates uniform variables between 0 to 1. It creates n times. So it creates 1,000 times for in range of 10,000. So for in range of 10,000, I am going to create values between 0 to 1,000 times, and I am going to add such values actually. So when I add such values, see it clearly, even though I have conducted 10,000 trials of 1,000 samples, plotting it shows that it still follows a normal distribution actually. See, this clearly proves our central limit theorem actually. Okay, so now so that we have understood something about probability, let us go something into statistics actually. Let us understand something about statistics modeling actually. Simple linear regression, multilinear regression, logistic regression, gradient descent, cross entropy, all those things. So you would have studied in your classes simple linear regression actually. So to perform such linear regression, what we have to do in Python? So I am importing certain libraries called import numpy as np and matplotlib as npy. This is something new. So again, to install such things, again you guys have to do something called this. So you have to first run this pip installer, and then you have to run this code. So since I have already done it, I am not going to do it here actually. So I'm calling a linear model from the sklearn, and I am importing the linear regression which we wanted to do. So what does a linear regression? How to call the linear regression here? So I am declaring a variable called x actually. So x is only one independent variable actually. So I am reshaping it to -1 to 1. So it will be a single column vector actually. So this column vector and this is a row vector actually. So this reshape does it converts into a single column vector. So instead of one, if I put 1 comma -1, it will convert into a simple row vector. So I'm converting every x element into a single row vector, single column vector. I'm keeping y element as a single row vector. So again here I'm calling the linear regression function actually. So I'm calling the linear regression function, I'm putting a dot fit. So if you want to perform a linear regression, this is how you should call. Model is equal to linear regression, model dot fit, or what you can do is you can do something like this actually. This both ways works fine actually. So I have done a linear regression, I have put a dot fit actually. So now all the values inside this dependent and independent variables gets inside the linear regression, and the model is being plotted actually. Fine. Now we have to plot for something. We have to predict for something using this trained linear regression. So I am for the easier sake, I am just inputting the same variable which was used to plot this x actually. It was used to train this linear regression. I am predicting the same variable of x actually. So y prediction says the values of the corresponding values of x where it has been regressed by the linear regression on x. So again here I am plotting up something called scatter plot. So what it does is it will scatter all the values of x and y. It will just give you a plot where the values of x and y is shown as dots. Plot x comma y. So it will plot values of x and y as a line. It will plot this as a line actually. So then this is same, this is similar. So title gives name as a title, label, label. So what does plt.legend does it gives a legend to it, actually, legend to a plot, actually. So you can see in the plot, this is the what I'm trying to say by legend, actually. So x and y is plotted, and this is the regressed line, actually. So this is the fitted line which is y predict corresponding to x. So you can clearly see, since it's an ideal case, all the values are closer to the regressed line, actually. So this line is able to correspondingly map the values in x. So some assumptions which we take in a linear regression is linearity, independence of error, homostadicity, and the normality of residuals, actually. So homostadicity, it says that if it is homostatic, all the random variables should have finite invariance. If it's normality of residuals, we say that all the values, all the random variables, all the residuals are normally distributed. We assume such things while doing linear regression. So residuals, the leftover, actually. So what I'm doing is, I'm taking the residuals of y minus y predict, actually. So the residuals of y minus y predict has been plotted across this, actually. So the error between the predicted as well as the actual y values, actually. So this has been shown it as the plot here, actually. So from 0, some values are closer to 1, some values are closer to 0.75. So multiple linear regression. So it would be having one dependent variable and two independent variables. Remember, we have done there using single independent variable. Here we are using multiple independent variables, single independent variable x, and here you are using multiple independent variable, actually. So here multiple sets of variables are there, actually. So I'm calling them multiple sets, and I'm using a linear regression so that it will be able to plot regress even in the case of multiple independent variables, actually. So linear regression dot fit, I'm calling the x dot multi, y dot multi, and I'm calling the dot predict function. And for the simplicity case, I'm using the same input x multiply. So we get a slope of 1 and we get an intercept of 1, since it's an ideal case where the same input is getting predicted as out. So remember this case, actually. So this is another example of multiple linear regression. I'm giving multiple variables, actually, two independent variables. Remember, the first we have simple linear regression, we have used 1x. Here we are using 2x, two independent variables, x1 and x2 and y. So what I'm doing is, I'm combining both of them into a single column stack, actually. Single column stack, so that it can be fed inside the linear regression dot fit, and I'm using the same variable y, actually. So these two has been made into a single stack of columns, and I'm fitting into so if you want to know what a single stack of column is, you just have to just print it and see. I'm leaving this printing to you. Just look at how it does. So linear regression dot fit, so it does this, and so I'm putting multiple linear regression. I'm calling a dot predict function inside this multiple linear regression. So just wanted to since it involves multiple linear regression, I'm using a multiple 3D plot where you can see the hyperplane separating the variables will be a 3D plane, actually. So again, I'm plotting all the values of x1, x2, x3, and I'm creating certain mesh grid for a 3D plot. This I'm calling linspace to show continuous set of values between min of x1 and min of max of x1, min of x2 and max of x2, and I'm calling mesh grid, and I'm putting a range. All this will create a mesh of grids, and then I'm calling the y grid to be model dot coefficient, and I'm calling the coefficient. I'm calling the coefficient of 0, that is slope, intercept, x grid. Yeah, model intercept I have grid, x grid I have grid, actually. So y grid is a sum of all this, actually. So I'm just plotting it as ax plot of surface, actually. So this comes out. So x dot set label is this. So the resultant will be plot of this. So it is a 3D plane where a hyperplane is separating all the values, since it involves multiple independent. So something about multiple linear regression actually. So logistic regression actually. So logistic regression uses a binary outcome actually. So to perform such things, I have declared two variables, x logistic and y logistic. Here I am giving certain values, but in the y I would have declared it as in the term of binary, zeros and ones. Remember, here I would have been declared it in terms of binary. Since it is linear regression, it can regress. But in logistic, we have to give y in terms of zeros and ones. So logistic regression, I'm just calling from the sklearn linear model, I'm calling logistic regression. I'm just fitting the values of x and y. Just for the simplicity's sake, I'm inputting the same variable which was fitted inside it, and I'm trying to predict it using this predict probability x logistic. So the value predicted is such things 0.9, 0.6. Such values are predicted actually. And the predicted possibilities for each class actually. So the values of 1 to be falling in the class 0 is 0.9. The values of 1 to be values of 2 to be falling in the 0th class is 0.8. Whereas in the case of 3 points of 0 to be point of 3 to be falling the 0th class is 0.6. Whereas 4 to be falling in 1 is 0.6 and 5 to be falling in 1 is 0.8 actually. So correctly it has predicted since it's a simpler case. I hope you understand this probability. So 0.9 with 0.9% of probability assurance or confidence, it can say is that this element will lie to the first class, that is 0. Similarly 0.8, whereas 0.6 it's a little less, 0.3, 0.6 with the first class and 0.8 with the first class. Then since we have understood about some methods of linear regression, let us understand something about cross entropy loss. So cross entropy loss, it's a loss function which we use it for calculation, use it for calculating certain loss in classification problems. So it measures the difference between true labels and probability predicted. So what I have done is I have just taken the formula that summation yi 1 minus log of 1 minus yi into 1 minus yi into log of 1 minus yi. The same function I have just written in terms of a formula actually. So since I'm using summation, I'm using a function called nmean actually, np.mean. So it just calculates this function and it just create cross entropy loss like this. So if you want to use this function somewhere in your networks or in your codes, or if you want to simulate something, you can write it as a function and you can just give the input of y probability and y true actually. So it will give the resultant of this actually. You don't need to write it as a single function. You don't need to write it as a single code like this. Instead, you can make it as a function and get the output. So resultant cross entropy loss is this. Finally, let us understood something called gradient descent actually. How to implement gradient descents in a Python code actually. So gradient descent is just to find minimize the cost function. It will find the steepest descent actually. So to perform it actually, so we have taken two variables and I am giving two variables x grid and y grid, and I want to find the gradient descent. I want to find the theta final of the gradient descent actually, the theta and the gradient descent actually. So does it I'm giving a learning rate of 0.01, I'm giving an iteration of 1000, I'm declaring both the values of x and y, and I'm calling this length of y does it gives the length of all the elements inside y, and I'm initializing this. See, this is one of the important stage where we have to, when we know the number of values inside certain list, we used to perform something called initialization. So here we have perform something called np.0. So it will create two elements inside this called two elements inside the list with zeros and zeros. So there will be a list with 0, 0. Then I am adding a bias term. Since we need to know a bias term actually for calculating gradient, I am adding a bias term called np.c, np once again. I am giving a predefined range between m of 0 to 1. So based upon the value of y, it has to, the number of ones has to be dynamically changed actually. So here the value of y is 1, 2, 3, 4, 5. So np dot of 5, 1, x, the value of x actually. So 1, 2, 3, 4, 5 will come here, and the length of 5, 1, np dot 5, 1s and x. So np dot c of 5, 1. So this will create a constant of xp. So this will create a similar bias term which we need for gradient. So I'm taking a range of all the iterations, which is 1000, and I'm just using the formula for gradients. 2 by m star of x by b, that is bias term, then followed by a dot matrix of x underscore b, which is the bias term, and then theta, value of theta minus y actually. So this whole term minus y, this whole term minus y. So this, then I'm just updating the resultant gradients with the learning rate actually. So every time the gradient comes, it has to decrement by a factor by the range of this 0.0. Let us assume that the first gradient is 1. So at the result of theta, it will be 0.09 actually, 0.99. So since we are subtracting by 0.01. So similarly, the gradient gets decrease for 1000 iteration, it will keep on decreasing. So we will get something called gradient descent actually. We are calculating the gradient, we are calculating the slope when we are trying to find the steepest slope in which the error is minimum actually. So this is something to represent gradient descent. So here what it does, it will return the value of theta, which is minus 0.94 and 2.15 actually. So I guess, so in this class you have understood some implementation of Python for a biomedical statistics class. So we have initially started with probabilities, where you understood random variable, the expectation of random variable, variance of a random variable, center limit theorem, some distributions we have gone through, how to plot a distributions we have gone through, normal, binomial, Bernoulli, Poisson distribution we have gone through. We have shown a good example of what it means by a center limit theorem. So when a large number of trials and large number of samples is there, and we assume it to be identically independent random variables, and the sum of all such things would be following a normal distribution actually. So we have shown that also. Further, we have understood some terms in statistical modeling, such as linear regression, logistic regression, multiple linear regression, some cross entropy laws, just to show you that such things can also be implemented in Python actually. Cross entropy laws, and finally gradient descent actually. So with this I am concluding my classes actually. So thank you.